Hello, my name is Kevin Piers with Exfo, and today I'll be going over how to set up Exfo's DWDM OTDR. So the platform I'll be using today is the Max platform. If you're using one of our FTB platforms with the DWDM OTDR, once we launch the OTDR screen, the interface will be very similar, so this training is still relevant for our FTB products. So from the Max platform, you'll see that I have the Max 740C. Now this unit is a combo DWDM OTDR and optical channel checker. I'll only be using the DWDM portion for this training. So I'm going to go ahead and launch the OTDR. And once I'm in the module, you'll see that we are in the source tab. So this unit will double as a source as well. So you'll see here on the left that I can change my channel filters, 50 gigahertz, 100 gigahertz, 200 gigahertz, or favorite channels. You can either have it continuous or you can modulate if you're using some sort of modulation detector like a power meter or a live fiber detector. Before we get into the OTDR, we need to set it up first. So over here at the right, you'll see the menu system. So I'm in the main menu system. If you find yourself in a deeper or different menu, just go ahead and hit home or back to get you back to the main menu. So starting from the bottom here, we'll start with user preference. Within user preference, this is where you'll set your distance units, whether it's kilofeet, miles, or kilometers. In this case, I will set it for kilometers. And for default view, this is a preference. So after the test is complete, I like it to go straight to the event table. Set your default save location. By default, it saves into Data, My Documents, OTDR. And then your default file format. .trc is Exfo's proprietary format that you can open using Fast Reporter. It provides more comprehensive information. Or you can do belcore.sor if you need to stick with an open format from Telcordia. And of course, the rest of them here are all options, whether you generate a report on save or if you automatically save the measurements. These are all options that you can choose. And then within graph, this is where we can do things like show the grid lines, invert colors, those types of things. And then reports. So if you do create a PDF report, you can slim down the report by removing some of the sections if you'd like. In this case, we'll just leave it alone. So once I have those set, I'll hit OK. Then I'll go into test configuration. Now, test configuration, just like with our other OTDRs, are where you set your pass-fail thresholds. So always revert to factory settings if you don't know where to start. And here are the settings that we have here. So this is where you can set your index of refraction. If you know it, your backscatter, helix factor to compensate for any sort of twisting if you know what it is. Now down here where it says calculation pass-fail thresholds, if you're using a launch cable, then you want to make sure to include span start if you are using a launch cable. If you're using a receive cable or recovery cable, you want to include spanned end. If you are just testing to an open, you want to uncheck include spanned end. And over here on the right, I would just leave these at default unless you know exactly what you want to set. These are detection thresholds, so don't show me a splice if it's better than .02, things like that. Under pass-fail thresholds, this is where we can set them for each wavelength. So in this case here's 1550. I'm going to revert to factory settings to give you an idea what it looks like. And in this example, I care about splice loss, so I'll set this to a value that I like. So these are just some values that I typically use. So this is where you would input your company specifications or your customer specifications. I'm not testing through a splitter, so I'll remove that. Reflection I do care about. I like this between neg 40 and neg 50. I really like it closer to neg 50. I'll set it for neg 45 in this example. If it's an APC connector, then I usually want it at least neg 50 or better. I usually turn off fiber section attenuation. This is the loss per distance, but this is for each section, not for the span, but for a section. So if you have two splices that are half a kilometer apart, this is going to measure the loss per kilometer of that half kilometer. And just like trying to get miles per gallon on your vehicle, you need to drive more than a couple of blocks to get a good average. Same thing with fiber section attenuation. Be careful with it because you can get misleading or false fails because we are testing short distances possibly. Now, if you know you have long fiber sections, then this is something that would be useful for you. I'm going to turn off span loss and span length in this demo because this will vary depending on the span. If you have an engineered loss that you want to do pass fail to, then of course you can input that. And for span ORL, I like 32. So most customers are between 27 and 32, with 30 to 32 being the most common that I see. So you do this for all of your 1550 settings. Now that I have that set, I'll go and hit OK. So now we have user preference and test configuration complete. Now we can go to identification. So identification, again, I'll revert to factory settings here. And then from here, I'll go ahead and set up all my information. So I can put in my company name here. So I work for Expo. And my customer, whoever my customer happens to be at the time. And of course, your operator name. So this is all your standard identifier information here. If you have a job ID, you go to job ID in there. I encourage you to fill as much of this out as possible. But what's really critical is what we call the 5 identifiers. So down here to the bottom left, we have several identifiers. And so these ones right here are our 5 identifiers. So the last one is none by default. So it's a custom identifier. But these are identifiers 1, 2, 3, 4, and 5. So these are the ones that you need to populate as much as you can. So in this case here, I'll say my A location is Goodyear, Arizona, where I live, over to Phoenix, Arizona, Maine. So that's what I'm going to put for the first 2 there, right? And my fiber, I don't like having any sort of value in the prefix. I like it to be blank. I just want the numbers. So right now we're going to start at fiber number 1, but I like to have leading zeros. So I like more than 1 digit. So with fiber ID highlighted, I'll go to increment, and then I'll check auto increment for fiber ID. And under format, I will extend this down to at least 4. 3 or 4. I like 4 because there are larger cables like 1728s. So now it's going to start at 0001. And if I have a cable ID, I'll go ahead and put that. So I'll put a cable ID in here. Hit enter. Now, if you look at the file name preview here in the bottom left, it's not really telling us much, is it? So if I save this, it would just save it as 0001.trc. So over here under file name, I want to include the different identifiers into the file name. I like to have A location. I like to have B location. If I have a cable ID, I'll add that in there as well. If I want to add direction, if I want to add a custom file name into that, I can do that as well. If I want to include my job number, because that's what's really important to me, then I can do it that way. So whatever makes sense for your naming convention. So right now it is cable ID, fiber ID, location A, location B. I like to have cable ID and fiber ID at the end. So with cable ID highlighted, I'll hit these arrows to the right to shift it down. And there it is. And then under fiber ID, I like it at the very end, so I'll shift it down as well. And I like to have a underscore as a separator, so it's easy to read in my file explorer. And now my file name is Goodyear to Phoenix, cable number 1, fiber number 1. That's a really good naming convention for me. I'll go and hit OK. And then that'll be my next file name you see down here at the bottom right. So now that I have everything set within my configuration, I can start deciding on my test here. So I'm going to go ahead and select the OTDR tab. And you'll see here we have channel filters. 50 gigahertz, 100 gigahertz, and 200 gigahertz. 100 gigahertz is what we see the most in a metro environment. 50 gigahertz if you're deploying ROADMs. We usually see this on the core side or on the line side of the service. But whatever your spacing is, go ahead and select it. Because once you select that spacing, then the channels that you can select will open up for you. So 50 gigahertz obviously would have more channels. So the channels are broken out into the ITU channel number, a frequency, and a wavelength. So depending on how you record these different wavelengths here, or channels. If you are doing the same channels over and over, so if you have 8 or 12 common channels, when you highlight the channel, if you hit the star here to the right, you can favorite that channel, which is a really nice thing to do, because with favorited channels, if I go down to channel filter and pick favorite channels, it'll only show me the channels that I have favorited and nothing else. So that really slims down that long list for you. And you can sequential acquisition these channels. So if you have 4 different channels, you want to sequence from one through the others, you can do that as well. So now that I have my wavelength set and I have all my configurations set, now it's time to start looking at setting up the test. It's always recommended to use a launch cable. So down here in the bottom right, you can select these 3 little dots here, and this will allow you to null out your launch cable. I do have a launch cable. It's about 150 meters long, so I go ahead and input that in there. And down here, you have your custom ranges and durations. So if I need to add in a custom range, so for example, there's 260 kilometer on the range here. Well, this test set, it cannot test 260 kilometers. So I'm going to go ahead and highlight it, and I can create a custom distance. I can go in there and say, I want a 0.5 kilometer. And then now on my selection, there'll be a 0.5 kilometer. So this is just a nice little tip here. The rest of these advanced parameters are options. Remain in auto setting, I do not recommend. I do not recommend using auto in a DWDM OTDR as a common practice, because one big issue with the DWDM OTDR is if you use auto mode with a DWDM OTDR and you're very close to a DWDM transceiver like an SFP, it is possible that in auto mode that the DWDM OTDR can damage the transceivers or the SFPs. So this is really important to understand, because what happens in auto mode is the OTDR will range to determine the distance. And all OTDRs do this. And it'll range at a very high pulse width, 20 microseconds. So you're coming out plus 15 dBm or more for a fraction of a second. But that's enough if you're close enough to the transceiver that it can possibly damage it. So I recommend never using remain in auto settings as a permanent setting. Auto mode, if you know what you're doing on a dark fiber and there's no transceivers nearby, that's all right. But as common practice, I wouldn't use it. I'll go ahead and hit OK. So now I have my launch cable nulled out. You'll notice that custom distance I put in is in here. So there's my 0.5 kilometer. So now we're ready to start testing. So how do I test with the DWDM OTDR? Well, the first thing I'm going to do is I'm going to determine my duration, believe it or not. So duration is how long you're going to run the test. The longer you run it, the more noise you clean up. So you're able to get away with shorter pulse widths at longer distances, or you're able to get away with longer distances in general because you're allowing it to clean up the noise. So I normally do not test less than 30 seconds in a production environment. If it's a very short span, depending on my need, I can go shorter for sure. If I'm in a maintenance situation, then I'll increase my time to at least 60 seconds. I'd rather test an extra 30 seconds and allow it to clean up more noise so I can get a cleaner acquisition than test something 30 seconds faster and then miss some information. So in a maintenance situation, I like to use a higher averaging time. If I'm doing high count fiber testing, which is not typical for DWDM OTDR testing, but if I was doing a high count fiber testing for some reason, then I would bring then the time would really matter to me, because 60 seconds on an 864 at one wavelength is 20 hours of testing. And so time really matters to you at that point. But in a normal situation, in a metro environment, I start with at least 30. In a maintenance situation, I start with at least 60. And I'll use the shorter ranges if I just need to do a quick acquisition to find something. So in this case here, we'll just leave it at 30 seconds. So now that we've decided duration, we have range and pulse width. So here's how I determine the best settings. I used to use auto mode quite a bit and then adjust from auto mode. But as I mentioned earlier, auto mode in a DWDM OTDR can damage your optics. So I've adjusted my training a little bit. So here's what I do. I drop everything down to as low as it can go. In this case here, by default, it was 0.9. So I'll leave it at 0.9. I'll drop my pulse width down to, 5 or 10 nanoseconds, whatever it happens to be. I'll click the real-time button here. So you notice the start button is up here by itself. If I click the real-time button, it adds a real-time button next to it. I'll go ahead and clean and inspect my connectors, plug in my launch cable, plug in my network, and then set these low, and I'll hit start real-time. So it'll go in there and then do a quick acquisition in real-time. It's going to be noisy probably. So the wavelength is now tuning, so that takes a second here. And once it's tuned, you'll see real-time up here. Now, mind you, I'm going over VNC over my network, so the refresh time is not as real time as I see it on the test set. So you notice I got a noisy trace here. So the first thing I'll do is I'll increase the pulse width slowly until it starts to flatten out. And as I add more power or more pulse width, you'll notice I launch higher on the power scale, and I get a cleaner looking trace. Once it starts to flatten out like this, then I'll increase my range to see if I can find the end. You can skip around a little bit if you'd like. So there's 2.5 kilometers. Let me go to 5 kilometers. So there's the end of my fiber there, I think. Just to make sure, I'll go to 10 to make sure it doesn't recover. And it doesn't. You want to make sure it falls into the noise floor and stays down there. So I can go back to 5 kilometers if I'd like. This is a little close to the end than I like. I usually like the end of fiber to be around here. But in this case, we'll leave it alone because it'll give us nice visibility here. So I have a nice clean trace at 50 nanoseconds in real time. My range is set for 5 kilometers. My duration is going to be 30. So I leave range and duration alone. I'll stop real time. Now, real time is always going to be noisier than averaging time or average time. So my pulse width is always going to be less than 50. So I'll drop this down to say 30. And then I'll start my average test. And so I'll let it run for the course. If the trace cleans up within 30 seconds, then I'm going to try 10 nanoseconds. All right, so what I'm looking for is how low can I go with the pulse width and still get a nice clean trace within 30 seconds. So at 30 nanoseconds, it's starting to clean up really well. So this is fairly smooth here, so I'm going to stop it. Instead of just staring at it for the next 15 seconds, I already see that I have a good trace. I'm going to go and then drop it down to 10 nanoseconds. So the shorter the pulse width, the better your resolution. And so now we're testing it at 10 nanoseconds. So let's say after 30 seconds at 10 nanoseconds, it is a nice clean trace. And then we tried 5 nanoseconds and 5 nanoseconds was noisy. Then we would use 10 nanoseconds, right? If there was stuff at 5 nanoseconds that we saw that we did not see in 10 nanoseconds, then I might increase the duration to clean up the noise to see if I can get away with a shorter pulse width. So it's kind of like hot and cold water mix here. So within 30 seconds, we have a nice clean trace here. And in this case, I left sequential acquisition on, so it's actually going to test 2 wavelengths. So that was an oversight on my part. So normally you want to uncheck sequential acquisition unless you want to test all of the favorites. So in this case here, we're testing 2 of the wavelengths or 2 of the channels. Not a big deal. So now that we're done, we can start looking at our values here. So if you notice here, right at about 160 meters here, which is where our launch cable's at, you'll notice that we have a non-reflective event. It shows it high loss for a splice. This is actually not a splice. This is a really good APC connector on my launch cable. So if this ever happens to you, over here to the right, you see this little pencil. I can click this pencil and I can say, you know what? That event number, oops, I got the wrong event selected here. Go to event number 1 here, sorry. So this event here, number 1, is actually a connector and not a splice. It's just a really good APC connector. I can hit this pencil here and I can change it to reflective. And I can put a note there if I'd like. And you'll see the reflection is minus 74.6 dB, which is a really, really clean APC connector here. And the reason why it wasn't detected, if you go to test configuration here, you'll notice under link definition that the detection threshold for reflection is minus 72. What that means is any reflection better than minus 72, don't even show me. So this helps clean up the event table some. So in here, I went ahead and added it in. So now we have our launch back in there. And then at this point, it's just really looking at your results here. So I have a video that talks in depth about the analysis. But in this case here, I'm looking for anything that fails. So I have my connector set at 0.5 dB with a minus 45 reflection. And so we're good there. Now here we have an emerged event. We're not doing pass fail on it because of its emerged event. And so because it's merged, we don't have a threshold for a merged event. In this case here, if I zoom into it, you'll see we have 2 connectors that are very close to each other. This is actually a test set that I have in the in my network. This is a variable attenuator. This is the port in and the port out of this variable attenuator. It is a little dirty, so I'd probably going to clean this up after we get done with this training here. But this is a merged event where there's two events very close to each other and we can't separate them. If I reduce my pulse width down to 5 nanoseconds, we might be able to do that. But these are very, very close to each other. And so as we go down here, we can see all the different connectors. This one's a nice clean connection there. We have another merged event here. We have two very close to each other. 5 nanoseconds will probably pull this apart. So this is when you start looking at, well, should I go to 5 nanoseconds? Because I see there's a merged event there. Maybe I can separate them. So I can go to 5 nanoseconds here and maybe increase my averaging time a little bit to compensate for the noise. And then if I retest with a shorter pulse width and a longer averaging time, I might be able to take those apart. So that's something that you could try. And one thing that I did notice is you always check your launch conditions. And you see here, I'm launching at -36, which is really bad for an APC connector. So I'm going to go ahead and clean that and then retest. So I went ahead and re-cleaned that launch port connector here. And let's go ahead and retest. I'm going to leave it zoomed in because we'll see right away if that peak drops. You see that big peak that was just there? It was right around here, I believe, for the top of that peak. And then now it is completely gone. This is the importance of cleaning your connectors. And during training, sometimes I'll rush through it. But at the same time, I always appreciate it when this kind of stuff happens, so that way I can show you some of the issues that happen here. So this is a little bit more than just a standard DWDM setup video. And if I want to record this, I just go ahead and hit save. And if I want to generate a PDF report, I can go ahead and hit report here, give the PDF a name, give it a save location, then I'll have a PDF. And that's it pretty much in a nutshell. How to set up a DWDM OTDR with a little bit of launch condition troubleshooting and resolution adjustment. My name is Kevin Pearies. Thank you very much.